Hello there, in today's video I will show you the last of the Christmas ornament series. Today it will be a more technical design, so let's go have a look and find out how we do that in Grasshopper. Alright, for this pattern we will start with the geodesic dome again, as we did with some of the others. It's from the parakeet one, right? So we have to define the radius. And if you remember, we can use the dome frequency to basically control the density of the dome. And to keep it a little bit lighter, we use 2. Okay. So then we again extract the face boundaries to get the curves. And we apply the dual graph of the Weaverbird plugin. And that basically removes half of the curves, and from these more triangular shapes we receive hexagons. And the hexagons, like, typically technical in its aesthetic, right? It's used for very many of these futuristic looking things. So we will use that for our purposes and create, let's say, a futuristic looking Christmas ornament. The next thing is we would need to scale these curves, but I want to scale each of these hexagons by themselves. In order to do that, we have to scale them towards the center. So we use the polygon center command, and from here we use the average of polyline edges, plug it into the center, and now you see that from this sphere we go to still a sphere, but with the hexagons being scaled individually. And then what I want to do is to move them, and I want to move them inwards so we can do a loft. So basically I want them to move normal to their position based on the spherical object. So I will construct a point in the center. Construct point, right, of our geometry. And now I will create a vector based on 2 points. So one of these points is the origin, and the other points are the centers of each of the hexagons. And that way I have basically now defined a vector that is normal to the spherical surface at the point of the hexagon. And this we will use as the motion, but now, like, they are really long, right? So we want to be able to control how far we move the whole thing. So we have to use the amplitude and plug in a value. Let's go for 0.3 and make it negative. And now we use this into the motion, and you see that we move this ever so slightly inwards. We can also increase the distance, but that's basically what we want, right? And we could actually already go ahead and do the loft. A mesh loft. And for it to work, we have to be sure now it's like basically one big list with a lot of curves, and we want this to be grafted. So I take the graph tree, take this one and another one, which is basically our outer hexagon, the original ones, right? So they together create an interesting intersection. So I take these dual graph hexagons and plug them in, holding shift to add, let's say, a second input to the mesh loft. And now we have this interesting design, right? So I think it's really cool. But did I not do negative? We don't even need the negative. For the effect that we are looking for. So, alright, let's get rid of it. Mesh left, and then if you still feel like, okay, this is a little bit too technical or too sharp, you can do, let's say, first of all, mesh join them. Now you have one single mesh, and maybe you want to use the Capmo-Clark subdivision to make it a little bit more smooth and rounded, right? And now you see this is much more of a circle than a hexagon. So if that's something you prefer, then go ahead, use this one. But again, I mean, this is not the basic algorithm, rather simple, and you can go in everywhere now and make refinements as we go. So what I think could be interesting is to adjust the scale of the hexagons. So maybe we deactivate this one for now. So instead, now it's a constant factor of 0.5. But what if we adjust that? Or let's just add like some points. Here, why not for now? Oops. Negative 25. Then we copy one. And these 2 points, we add here. Set multiple points. Now we have basically based on our geometry in Rhino, we have some reference points compared to this whole thing. Okay, what is the radius? Oh, okay. Anyway, we can still move it up. 25, move it down. 25, so now they are at the north and south pole of the dome, right? And now we pull points to get the distance values again. So this is the geometry that pulls, and the points that pull, we take the centers to be pulled. Okay, now we have a lot of distance values, and then we remap them as we maybe already know. So we have the values, we define the bounds, and we leave it at 0 to 1. Why not? I think that's a realistic scaling factor. Then we again add the graph mapper to gain finer control. Easy, just do like a preset something. And now we have several values here. And now let's see, 642. Actually, we can look here, 142. So it should work if we plug this in as the vectors. Okay, so that's the problem. No 0. Double click in here and make this 0.1. And now you see already like the effect it has, right? The closer they are to the points that we specified, the smaller they get. And now we have the control to make sure this looks the way we want it to look. And maybe these are a little bit too small. So I think now we have some interesting geometries. Maybe also do like this a little bit. And then our mesh has a very different appearance already. Okay, much more dynamic. Yeah, maybe we just bake this one. All right, I think this is pretty cool. So at some points it's see-through because the holes are really big, and at some points it's almost very solid because the holes are so small. And then maybe we can create a mesh sphere again with the radius of, let's just try, and let's just increase the count a little bit. So yeah, if we bake this one now, then we can print this as a solid without problems and still get this nice effect. And what you can also do, if you want to keep it a little bit more random, so you take your geometry and you populate it, I don't know, with 3 points randomly. Okay, so let's group these guys and hide them. And now we take these points instead of our reference points. And then, oh, let's go back to the normal shaded view. We get like a quite different design, which looks a little bit more random, because where our points are, so not these points, but these points, there they are small again, right? The holes. So maybe I'll just print it as well or bake it so it's visible after all. Right, so you see it's now less uniform. It's not just the top and bottom, but it's like we have several fields of density that change. And I think this is really cool. And again, together with this guy, you could create something that is really interesting. Play around with the graph, do whatever you like, try different things. And yeah, that's basically all of it. Now I showed you, I think, 3 or 4 different ways to create Christmas ornaments within Grasshopper using like spheres, geodesic domes, and other rather basic components. I hope you liked it. And if you did, enjoy the show, subscribe maybe, and follow along for what's coming up next. Thank you very much.